Hello my dear children of class 11 science. Today again I welcome all of you through this mode of teaching. That means we are following already YouTube mode. And in today's class we do the last chapter. Children, the last chapter under unit number 8. Okay, and the chapter name is second law of thermodynamics, and this is basically the heat engine. Okay, now this is a very important chapter under unit number 8 that we are already dealing, that is called heat and thermodynamics. And children, at even told in the previous video also that this unit number 8 is very important for chemistry also. Okay, now before we start with the detailed explanation of second law of thermodynamics, basically in this video we do the introduction of this chapter. Okay, so we start with the introduction of the chapter. So before we start with the actual statement of second law of thermodynamics, okay, so we try to understand why the second law of thermodynamics has to be made. Okay, so for that we go back to the first law of thermodynamics. Okay, that means before we proceed to know about the second law of thermodynamics, we will try to know about the first law of thermodynamics, and most importantly the problem or the limitation that occurs in the first law of thermodynamics. Due to that, the second law of thermodynamics was forced to meet. Okay, now first law of thermodynamics. First law of thermodynamics. Yes, children, you learn in details about first law of thermodynamics. Now this law of thermodynamics simply gives the law of conservation of energies. This law of thermodynamics simply tells the law of conservation of what? Energy. That means law of conservation of energy. Now energy, as you know, law of conservation of energy means energy can neither be created nor destroyed, but can be transferred from one body to another body, which means the total energy, just to tell you that the total energy of the what? Of the universe, total energy of the universe, okay, do not change. Total energy of the universe do not change means I write out this way also, delta E universe. Basically energy, total energy is expressed by letter E. Now delta E means the change in total change in energy of the universe is always 0. So change in energy of the universe 0 means the total energy of the universe remain constant. This is constant. Now there is another word for constant, as we use conserve. Okay, conserve. That means the energy always remain constant or conserve. This also means that the equivalence of mechanical work and heat. Equivalence of mechanical work and heat is the main statement of first law of thermodynamics. Okay, but you know, in the universe, energy can be observed in the form of mass, because mass can be converted into energy and energy can be converted into mass. Okay, now energy can be observed in the form of light, energy can be observed in the form of sound, etc. Okay, which means any process occurs in universe, then the conservation of energy is applicable. Yes, this is true. So any process occurs in universe, the conservation of energy is was applicable. That means the first law of thermodynamics is simply a what process? Like a spontaneous process. Okay, anything happens in nature in which the energy is always what? Conserved. And children, we accept this, that the energy is always conserved. Energy cannot be violated. Law of conservation of energy cannot be violated. Okay, that is simply explained by the first law of thermodynamics. But still, there are some limitation of first law of thermodynamics. Or limitation is also called drawback. And children, you have learned in the chapter of first law of thermodynamics only, there are some limitation of first law of thermodynamics. Okay, now the most important part is this particular law that is called first law of thermodynamics didn't tell which process occurs, which process does not occur. Means any process occurs, the energy is conserved. So means energy conservation takes place when the process occurs. But the first law of thermodynamics didn't tell about which process occurs in nature or which process does not occur in nature. Means it didn't tell whether the process will occur or not. So let me just add a point. First law of thermodynamics didn't tell what? It didn't tell whether the process will occur or not. That means this particular law does not mention the condition under which the such conversion means like conversion of energy and work, or work and heat can take place. That means this particular law does not what? Mention. This law does not what? Mention, the conversion. I mean the condition. This is basically the what? Condition, under which such a process, or we can simply use the word conversion, is possible. That means there are a number of limitations of first law of thermodynamics, and that first law of thermodynamics limitation is actually directed by the second law of thermodynamics. That's why children remember this part. Why second law of thermodynamics has to be made is because to rectify or to direct the first law of thermodynamics. Because first law of thermodynamics simply we understand the energy is conserved. But whatever way happens in nature, that means energy always conserved. But this is always not true. This is not always true. That's why we know that there are some limitation of first law of thermodynamics. So as I said already that it does not mention the condition under which such a process like conversion can occur or possible in nature, which means this particular law, the first law of thermodynamics, does not indicate the direction of heat flow. So let me just give you one example of it. When two bodies at different temperature are placed in contact, so what happened? We know the heat flows from body at higher temperature to a body at what temperature? Lower temperature. That means the law does not tell whether the reverse process is also possible or not. That means heat flows, as we know, heat flows from body at high temperature to body at low temperature. But is it possible that the heat can even flow from low temperature to high temperature? That means that this reverse process was not explained by the first law of thermodynamics. Means first law of thermodynamics simply say that in whatever way the two bodies are kept in contact at different temperature, energy transfer, so that the total amount of energy remain constant or conserved. But whether the heat which is flowing from low temperature to high temperature, is it possible or not? That was not actually explained by the first law of thermodynamics. That's why, as I said, heat can flow from hot to cold body, but does not flow from cold to hot body. Remember this. It can flow from hot to cold body, but cannot flow from cold to hot body. That means the direction of flow of heat was not explained by first law of thermodynamics. So this is one of the limitation of first law of thermodynamics. And children, there is another point that we need to keep in mind, and this is actually the limitation also of what first law of thermodynamics, which says that the first law of thermodynamics does not tell about the feasibility of a process, or the first law of thermodynamics does not tell about spontaneity, which means which process is feasible in real life or nature was not explained by first law of thermodynamics. So in a simple way, I tell you that this is one of the limitations which direct to form what law? Second law. That's why second law actually give the direction of first law. Second law give the direction of what law? First law. So there is some drawback in the first law. That's why it is to be formed what law? Second law. But children, we are still not defined second law. That's why I am just going back to the first law with their limitation, so that what is the reason that the second law has been formed. That part I am explaining. Now the next point that I want to add, children, for this process which occurs in nature is the natural spontaneous processes. Whatever process that happens in nature by itself, are irreversible. Irreversible means this happens only in one direction, but cannot happen by itself. The process may occur under certain condition, but the same process, reverse process, cannot happen by itself. This is very important. This is very true. Let me just give you one example. As you know, water fall from higher level to lower level. I mean to say water falls downward, is a natural spontaneous process in which energy conservation takes place. No doubt, that means the first law of thermodynamics is applicable, where potential energy at the greatest height get converted into what energy? Kinetic energy. But can you see that the same water can go back by itself to the higher level? It cannot go. Okay, that means any natural spontaneous process occurs which are usually irreversible. That happens only in one direction, but cannot happen by itself. Means all natural process cannot happen by itself. So this is actually the drawback which was not explained by the first law of thermodynamics. Although in this case, in this example, you see the energy conservation takes place. Okay, that means the first law of thermodynamics is valid. That means first law of conservation, energy conservation or law of conservation energy is valid. But as for the reversible process is concerned, okay, I mean to say when the same natural spontaneous process to occurs by itself, that cannot happens at all. That means not possible. Okay, I'll give another example. Like we take water in a beaker. We take water in a beaker. There's a water. Okay. Now if I put some salt or if I put some sugar also, no problem. Okay. We know that this salt or sugar, okay, will dissolve in water. So it's a natural spontaneous process. Okay. But children, you know, can you able to make the same salt and sugar back from this water, which is dissolved, that salt in water? It's not possible. Salt can be dissolved in water. Okay, it's a natural spontaneous process. Okay, but from that water dissolved salt in water, you cannot again form that sugar or salt. That means the reverse process is not possible. Okay, now I'll give another example of it. When we rub our hand, yes, when we rub our hand this way, okay, and you know work is converted into what? Heat. Whatever work we do, that is converted into heat. That means it follows the law of conservation energy. But when we keep our hand in the burning candle, okay, when we keep our hand in the burning candle, our hand cannot be rubbed automatically. Because that means work can be converted into heat. But that heat, all heat cannot convert into work. See, by doing mechanical work, we are converting that mechanical work into heat so that we can make our hand warm. But when we keep our hand, okay, in this way, keeping our hand in the burning candle, you cannot see that automatically our hand start rubbing automatically like that. That means that heat cannot convert again into work. Okay, so this is also one of the limitation of first law of thermodynamics. In a simple way, I can tell you that some process happens, but some process cannot happen. Now, children, I want to add another point with the limitation of what first law of thermodynamics is that this law does not provide any information regarding the nature of the source of heat. Yes, regarding the nature of the source of heat. That is, whether it is a hot body or cold body in which the heat can flow. Okay, that means first law of thermodynamics simply say that energy in whatever way it will conserve in the universe. But the conservation of energy, is it possible when there is any heat which flows from cold body to hot body or hot body cold body? That was not exactly explained by the first law of thermodynamics. Okay, so this is also one of the limitation of first law of thermodynamics. Now another thing that I want to add, this is the last point that I want to add regarding the limitation of first law of thermodynamics, and with this we come to the statement of second law of thermodynamics. Now as for first law of thermodynamics, all work can be converted into heat, which means mechanical work and heat are equivalent to each other. Okay, equivalent to what? Each other. As you know, all work can be converted into heat, but all heat cannot be converted into work. Remember this. All heat cannot be converted into what? Work. So that's why I want to add another point, that all work can be what? Converted into heat. And this all work which convert into heat is a what process? Spontaneous process. Spontaneous what? Process. Means it occurs in nature under certain condition and all, in which the energy is conserved. Okay, but all heat cannot, all heat cannot be what? Converted into work. All heat cannot be converted into what? Work. Yes, this is not true. It's not possible. All heat cannot be converted into work. But this is the case which was not explained by first law of thermodynamics. So as I said, first law of thermodynamics simply gives the law of conservation energy. Okay, work and heat are equivalent to each other, and all work can be converted into heat. But the reverse process is not possible. That means all heat cannot be converted into work. Okay, that means no engine or device cannot do 100% efficient. Can be 100% what? Efficient. Now this all heat cannot come into work is a non-spontaneous process. Non-spontaneous process. Where all work can be converted into heat is a spontaneous process. So whether it's a spontaneous process or non-spontaneous process, okay, that happens in nature, okay, all under this case energy is conserved, that is true. But is this spontaneous process occurs? That was not actually explained by first law of thermodynamics. That's why you see that there are a number of limitations we see in first law of thermodynamics, and due to this limitation, the second law of thermodynamics was made to form. Okay. So children, first law of thermodynamics didn't make any comment on spontaneous and non-spontaneous processes. But second law of thermodynamics is completely based on the spontaneous and non-spontaneous processes. That means second law of thermodynamics is actually based on the feasibility of the process. Okay, whether it's a spontaneous process or non-spontaneous process. And the detailed explanation and the statement of second law of thermodynamics you'll be learning in the next YouTube video. So in the next YouTube video, we try to understand the statement of second law of thermodynamics.